One of our tagline of our computer science course, as you can see now in the screen that I'm sharing, um, coming from Steve Jobs. Everybody should learn to program a computer because it teaches you how to think. The question is, how could you learn how to program? And that is leading me to our focus of discussion for the day, which is algorithms. You cannot do programming without understanding the basics of what we call algorithms. This is a very important basic concepts for you to proceed to programming basics. In this lecture, our key discussion would focus primarily on writing algorithms that provide solutions to problems using structured English, flowcharts, and pseudocode, and a separate discussion on the process of stepwise refinement of our algorithms, leading to simpler solutions for coding our program. Now, what is an algorithm? Let us have some history with regards to the origin of algorithm. The name was a coming from, we have what we call a mathematician in the person of Muhammad ibn Musal al-Khwarizmi, and whose tribe name was Latinized as algorithmi. So the word algorithm came from a Latin word algorithmi. So that is just to give you a brief history of what an algorithm is. Okay, we can find a lot of instructions, and these are considered as step-by-step instructions, not only to solve a problem, but to for us to follow whenever there is an emergency, or maybe an instruction from the textbook or from a cooking recipe. Most of the time, I use the recipe as an example of algorithm. You need to follow a step-by-step instructions whenever you're going to cook a certain recipe, and that's one of my passion, which is I'm also good in cooking. So every step should be followed. So cooking recipes, we have procedures also on how to evacuate during uh, fire evacuation, or when there is a fire, and then the furniture assembly or instructions, or whenever we buy um, some gadgets or some furnitures that has a instruction in it, and we need to follow it step by step. And of course, we have a washing machine usage instruction. So this step by step can be considered, or they are actually being considered as an algorithm. It is a step by step instruction used to solve a problem. Of course, they are used by both human beings and computers. In its brief discussion, and it is very um, brief description, computers requires algorithms to function. Of course, yeah, meaning these programs are in the form of algorithms, and they are usually come in the form of a software. Of course, computers differs from humans in that the instructions provided must be completely unambiguous. They must be clear and not open to interpretation. Algorithms for computers includes, these are some when we encounter later on, some software program instructions. These are in the context of computers. Device handling instructions, and of course, some data storage instructions. Algorithm from other readings that I encountered consists of sequence of steps. So it's just the same with the previous one, that it is a step-by-step instruction in order to solve a problem. Now, some of the considerations here are, under certain conditions, you may not wish to perform some steps, or there are some instances that there are a number of steps in a particular instructions are constantly repeated. When we write algorithms, especially this is already an offshoot or a basic concept leading to programming, we have a lot of basic programming constructs that is actually being integrated when we are going to create an algorithm, or later on representation of algorithm in other methods to represent your program before it is being coded into its equivalent syntax equivalent to its own, or whatever programming language that you're going to use. Number one here is the assignment construct. Usually, this is going to be an identifier. There is an identifier. Then you're going to what you call associate or store a value to a certain variable or identifier. Basically, these programming constructs are already been discussed in our IGCSE, so I hope we need to have a good simple recall on these types of basic constructs. Sequence, we know what is a sequence. Definitely, if it's a step by step, so there should be a sequence. It is performed one after the other, step 1, step 2, and step 3. And selection, would be an instance wherein your program would branch to another instruction, or would depending on the conditions, then what would be the next thing to be executed. So that's what we call selection. And one of the most common programming constructs that is usually being used is, of course, this is very, very, very important, and at the same time, the looping mechanisms or repetition. Always it is in our program. Always in whatever programming instructions that we're going to create, or any problem, usually it involves the use of repetition, iteration, or looping. Next, there are several methods to write algorithms. So we can represent algorithms actually there are 3 methods here that was represented. The first one, which is considered as a structured English, it is actually an English statement, or the statement or the representation of the algorithms or programs are simply closely related to our English grammar. So as you can see here, let us say the the algorithm here is, you're just going to input the number of miles and convert this to its equivalent kilometers. So you can see some numbers here. Okay, the numbers here represents the number of instructions or the steps. So step 1 is input number of miles. So you notice it's a complete sentence. Yes, very similar to the English grammar. The second one is calculate the number of kilometers. And then after calculating, this is simply you are going to convert miles to kilometer. After converting, what would be the next instruction or next step to be performed? And that is definitely the output, the calculated result as in the form of kilometers. So structured English is closely related to our English words for commands and mathematical operators. Alright, next one is pseudocode. It is a method of showing a detailed logical steps of an algorithm using keywords, identifiers with meaningful names, and mathematical operators. So pseudocode is considered as, it's no longer a full English text, but there are some shortcuts already on how are you going to create the pseudocode. Again, pseudocode and structured English, these are methods or other representations on how are you going to represent your program. So that would give you an idea to refine it. So because of this considered the methods, this would give an idea, this will be my guideline. So it's just like a blueprint of a house. Whenever you're going to build a house or build a building, a 2-story building, maybe a 10-story building, it usually requires what we call a blueprint, okay, that would serve as a guide. So if you can see here in the example, the pseudocode here is, yes, there is still inclusion of the English grammar, but comparing here, which is considered as a complete sentence, this one is, it was actually had been shortened. Yeah, input, enter miles, then you input the miles, and then kilometers now is miles times 1.61. So there is already an inclusion of mathematical operators or operations, and then definitely you're going to output the whatever is the computation. So it's very clear from here that they already have what we call a quite distinction to one another for the structured English and pseudocode. One of the best part that I usually discuss with my students, okay, the flow charting. I really enjoyed this one when I was in the high school also, because we also had the discussion of these different flow charting symbols. At first, I was very reluctant because of so many what do you call this one? Yeah, so many shapes, but I do enjoy in doing the flow chart because just to give you an idea, whenever I don't know the answer, I enjoyed only writing the start and at the same time writing the end, and my teacher would give me 1 mark already without the body of the program, this one. But of course, that is not a good practice. Your flowchart is, as you can see, it is considered as the graphical representation of your algorithm or program. So you can visualize. Of course, I'm not going to discuss here the different flowcharting symbols because we already discussed this one when you were in IGCSE, okay, in the topics in IG, okay, computer science for 0478. All right, so this is an example of a flowchart. So the shape here and the start and the end with the label start and the end, that's an oval shape. That is actually regarded as our terminal symbols or terminating symbols. The input enter miles here, this is actually a parallelogram. It shows what we call input output. And then the rectangle here is, you notice there is an operation, meaning mathematical computation here from miles to kilometer. So there is a process, there is an operation. So rectangle represents processing symbol. All right, and of course, yeah, don't forget the flow lines or the arrow lines. Okay, that shows the direction of how the program is actually being executed, instructions by instructions as per represented by the flow chart. All right. Now we need to go to the different programming constructs, and we're gonna compare how are we going to represent each programming constructs into its equivalent English structure, pseudocode, and flowchart. So the first one is the assignment and the sequence operator. Assignment or sequence is that, for example, the pseudocode here, let's say you are going to increment B. You need to place a value to A first, that is 50 to A. And then here comes now another instruction, this is B plus 1, so incrementing B. Sequence in such a way that, for example, when you're going to get the average of a number, of 5 numbers, you need to input first 5 numbers, store that in variables. After storing, then you get the sum of the numbers. After getting the sum of the numbers, you divide it by the number of entries that was included in your entry. So let's take a look here. You're going to set A to 50. So setting A to 50, structured English. The representation now is with the use of this one. Okay. Increment B. B now is B plus 1. Take note of the usage of the arrow key. Instead of equal sign, for pseudocode, it's always being used with the left arrow key. For flowchart is different. You need to draw. So since that is a process, you are creating a process here, you are going to set A or give a value which is 50 to A. So we make use of processing symbol here. Same with that of incrementing B to B plus to B to B plus 1. So B equals B plus 1, that's increment. Okay, updating. Next is selection statement. So this will just serve as a review to all of you as you have your IG discussion with regards to these algorithms also. So structured English, selection statement, an example if it actually there are choices that you're going to choose. If you choose one option, then what would be the next statement? If that statement is not met or the condition was not satisfied, then what would be the next? Is it else? So an example here is comparing two numbers, whether A is greater than B. If A is greater than B, then what statement you are going to place here? Maybe you can place there A is greater than B. As simple as that. You just display. So if you try to take a look at the discrepancy between the structured English to that of pseudocode, you might take a look that they are actually very similar. Okay, only that in pseudocode there is already an inclusion of the end if you are going to end the condition tracking or testing of the conditions. It depends if you have what we call a lot of conditions to test, or we call that one as nested if. The representation in flowchart is for flowchart decision making or selection. We call that one as decision symbol in representation of a diamond. So it branches out into two, either yes or no, or true or false. If this condition is met, then yes, what is the next instruction to be executed? If it is not, what is the next instruction also to be executed? Alright, repetition. One of the most important programming construct or major component of programming is looping mechanisms or repetition statements. So there's a lot. Okay, so the discussion of the Python equivalent will be done separately for our programming basics, as that would entail the use now of the Python compiler. We do the programming in Python. Structured English example is this one: repeat until A is equal to B. So what you're gonna repeat is the instructions. What would be the instructions that you're going to repeat? So again, structured English, English grammar, English words. For pseudocode, it's already different. Okay, this one. So repeat, what is the statement? Until A equals B, or yes, until A equals B. So you notice there's already an inclusion of equal sign here. But of course, pseudocode is not yet the syntax representation of the programming language. So it is just serving as the blueprint of your entire program. Loops in flowchart is always being manifested when there is a when the what do you call this one? When the condition is not met, what is the next thing to do? So usually selection and looping and repetition and selection always go together, because what usually in a usual aspect, what triggers a certain instruction to be repeated is because whenever a condition is never met, or whenever a condition is satisfied or true. Okay, so input and output statements is the same. Input A, output B, same instruction. Same with that of the pseudocode. As you notice with the structured English, we also have the input prompt A, input message B, and so on and so forth. Okay, and of course the parallelogram, this actually designates the use of input output. See, parallelogram here is an input or output symbol in flowchart. All right. One of the key things that we usually use in programming is the manipulation of variables or different identifiers. What is this variable? Yes, we had already a very good discussion also here in IG, and when we talk about what was some very important identifiers or rules in naming identifiers when we started the discussion about Python. So a variable here is in a computer program is a named data that can store named data stores then contains a value that may change during the execution of a program. It may change, or it can be modified during the execution of the program, as opposed to constant, because constants are considered as these are permanent values. In order to make programs understandable to others, variables should be given a meaningful name. So always, when you name a variable, it should be with the use of meaningful. So this would also guide the programmer or the users later on. What are these variables? So example, age. Age was equated to 40. Name, the same Sir June. Birthday or to date. Date today, example only, and the height 176.5. So this is an example of variables here, and they have already a value. Okay, they were given already a value. Other important elements of programming is we have also what we call logical statements. We also discussed this one already in our what we call this one, logic circuits, okay, with the use of logical statements. All right, a logical statement is of course a declarative sentence which conveys factual information. So what would be if two conditions are met? For example, if two conditions are true, what would be the next thing to do? How about if one condition is true and the other one is false? Okay, so usually that is with the use also of what we call the if else statement, or the what we call this one, the selection statement. Okay, selection statement. So let's take a look at this one, relational operators and logical operators. So the usage of and, or, and not, these are logical operators. Remember our discussion here about basic logic gates. And then relational operators, okay, usually equal sign. So take note of the symbols here. To, less than and greater than sign, not equal to. Of course, you know what is greater than, less than, and greater than or equal to, and less than or equal to. So please take note of the symbols being used here. So let's take a very good example before we're going to do some examples on how are we going to implement this particular worded problem into its equivalent pseudocode. And of course, there's already a representation here, advanced representation of the pseudocode in its equivalent Python. Okay, a person is eligible to get driving license only if his or her age is 19 and above. Otherwise, he is not eligible to get license. How can you write the above in a logic statement? So input age, you will ask the user to input age. If age is greater than or equal to 19, then output eligible, else not eligible to get license. So as a very simple implementation using the logic statements. All right, another example. So this is now with the use of logic statement wherein there are two conditions that you're going to test. Okay, so this is with the use of I can see here with the use of AND. So AND operation is that when both variables are true, okay, the output is always true. So here, a person is eligible to get driving license in Indonesia only if his or her age is 19 and above and his or her nationality is Indonesian. So you can get license if you're Indonesian, and so it's very clear here, and okay, it was mentioned that the and clause here, and that is with the use of and operator. So and there is both, okay, both conditions should be satisfied and it should be true in order for you to eligible to get license. Otherwise, if only one condition is met, the other one is not, then you are not eligible to get what we call a license. All right, so that's it. And please have time to study. So I will leave this to you and try to study also the many examples here as a practice also, and try to look into how are you going to implement this in a Python code. There is a variation of what we call if-else or selection statement. In cases the choices already exceeds around 3 or 4, then that is now with the use of what we call case statement. If you are going to implement if-else and you have how many options, let's say 10 options, then it's not also a very good programming style to use if-else, although the case statement is already working in Python. Okay, so if you have multiple options, then it is advisable to use the case statement. We'll execute this one or give a very good example here when we're going to discuss about the programming basics. And again, for the loop structure, there's a lot. These are the most common loop mechanisms that we are using. For to next. set of repetitions, repeat until. A repetition where the number of repeats is not known, so this is considered as a post-condition loop. The other one is while do. So while, you test the condition, and then do. If the condition is already met, then you need to end the while. So that is considered as precondition. Alright, loop structure. So these are some of the take note, these are pseudocode statements, not yet the Python equivalent. Okay, for counter 1 to 10, okay, output asterisk and then next counter. So a straightforward pseudocode, or yeah, this is already in the form of pseudocode. Counter was initialized to 0, repeat. So keep repeating, you output this star. Count, you need to count how many will be what goes on. This is the controlling variable, that's why it's considered as the post condition. Okay, when the condition in the last part after executing the statement was satisfied or was met, then that's the time the what goes on, the repetition or the loop mechanism will be stopped. In this case, it should be greater than 9. Okay, so you continue printing asterisk until counter is greater than 9. Alright, and for the precondition, the while here, while counter, okay, is greater than 10, do. So if this is satisfied, you continuously execute this output, and then you update the counter, which is counter initial value is 0 plus 1. That's already equivalent to 1. So while 1, you replace the value of counter here already, it will become 1. You compare that to less than 10. Is 1 less than 10? Yes. So you continue printing the asterisk. Okay. Same is true with the for to next loop. So there's already a examples here. Okay. So I want for the rest of these examples for you to have a look and try, or also for you to code this one. What would be the in practice, yeah, try to code what is the equivalent Python code, so that when we go to the programming basics, then we can actually execute this one. Okay, so as part of the reading assignment, okay, we have here the for next loop, repeat until, so examples, and of course the last part now is equivalent to while, do, or end while. All right, that's all for me. Thank you very much, and God bless.